Hi there, welcome to my talk. This is Vue.js, Progressive Web Apps and the Subway Dilemma. And it's basically a brief introduction how to start using Progressive Web Apps, why we need to take care about PWA, which are the problematics that we can solve, and how can Vue.js could help us in the process. So my name is Ignacio Anaya. I am from Argentina. That is my Twitter handle. If you have questions, feedback, or whatever, you can reach me there. And that's me playing hockey. When I am not traveling or coding, I am playing hockey. I know that you like hockey here too. I am JavaScript engineer at Block. Block is a company that provides blockchain solutions. I am ambassador at OutZero. I am Mozilla Tech speaker and also the organizer of Buenos Aires, that is the Vue.js meetup of Buenos Aires. We have a perfect match in the name. So if you're around in Buenos Aires sometime, you can reach me, and of course, you're welcome to the meetup. So I will start with a few questions. How many of you have experience with Vue.js? Okay, most of you, great. And how many of you have worked with PWAs before? Okay, some of you too, great. So the first thing that I want to talk about is the Subway Dilemma. And you're probably wondering what the heck is the Subway Dilemma. And I call the Subway Dilemma that frustrating experience that we face anytime that we start trying to surf the web, the internet, in the subway. Of course, maybe you don't have subways here, but you can face the same situation in elevators, undergrounds, I don't know, in a plane or in whatever place with a poor internet connection. And I am from Buenos Aires. We have subway there, but in Buenos Aires, using the web in the subway could be a minor issue. You have bigger problems. But imagine that you are in a friendly subway like Japan. So you are there, and it's probably obvious that you're not trying to hit a URL or a link in the subway because you know that it will not work. And that is, for me, the Subway Dilemma. That is the thing that we need to work. Why did not work? If I am in the subway with a page that I already cached in my phone, I was reading that outside the subway, then I enter to the subway, I don't have the page anymore. Everything was there before. So something's broken and we need to start fixing. And this is what we need to start fixing. This is our worst enemy as web developers. We need to face the Chrome dinosaur. We need to stop them. And the way to stop them, the way to win the game, it's using progressive web apps. Okay? So the idea is that to avoid that our users face this Chrome dinosaur again, and we can bring a full offline experience in the subway, in the underground, or in any kind of context that they can be. So this is the same I said before. It's not only the subway, it could be elevators, planes. Actually, before coming here, I put in my laptop some articles that I want to read in the plane. I let them open with everything loaded in the site. And then when I went to the plane, I tried to read there, and I faced the Chrome dinosaur. So that is the thing that we need to break. OK, so now let's move to progressive web apps. PWAs, it's basically a set of tools, standards, and best practices that we need to follow. It's important to understand that it's not a technology, it's not a framework, it's not a library. It's a set of things that we need to implement, and it's important to have in mind that those things could change in the future. Okay? Actually, you know that this ecosystem, it's growing fast, it's moving really fast, so we need to keep updated. Things that are now best practices, tomorrow could be bad practices. So it's a frustrating experience sometimes, because we finish with some implementations that maybe tomorrow are deprecated, but it's part of the game, so we need to have that in mind. And another important thing that I want to clarify is that most of the things that we are going to view now are not related to Vue.js, okay? Are things or practices or technologies that we can use in whatever kind of framework, Vue.js, Angular, React, or whatever kind of app in JavaScript. Are just basically web things. So I can define a PWAs as a web-based application, trying to bring a native experience, trying to bring the same experience to a user that it has using a native application. So more simple, it's basically an app, or are basically apps with links. And here I have some stats. maybe for us as developers are not relevant, but are important if we need to combine people to start using these technologies. And 13% of the stats are from 2 years ago. Probably it's not really accurate right now, but still works. But 13% of the traffic in the mobile internet, it's in the web browser, only 13%. And the 87%, it's done in the native apps. And why is that? Well, I think it's that because OS capabilities, because in the native apps we have push notifications, we have home screen icons, we can access the application directly from the home screen. We have device features like a camera, like the geolocation, like, I don't know, accelerometer. And we have mostly offline support. If I am in Twitter, I can read my tweets even if I don't have internet right now. But wait a minute, everything I mentioned, can we do that with the web? And the answer is yes, we can actually do that with the web. But let's suppose that it's not enough for you. Something important is that 80% of that traffic in the apps, it's made by the top 3 applications in the store. Probably Twitter, Instagram, WhatsApp, or you can imagine what kind of top 3. So most of the traffic in the web are done just in 3 applications. And this is really crazy, but 0 is the number of applications that the average user installs each month. Okay, so users don't, the average user does not install new applications. So it's really hard to reach those users, right? If we don't have something outside the mobile scope, it's really hard to reach them. And this is the one I like, the 13% that I mentioned at the beginning, the 13% of people using, or the 13% of traffic using the mobile web, it's reaching more audience than the 87%. So like 3 times more audience. And this is great because this is clear that we can reach more and more people using web applications even with less traffic. So why these applications are progressive? Basically because they're progressing in chains. We don't behave always the same ways, or they don't behave always the same ways. They try to improve with the time, they try to improve with the device, they try to improve with the hardware. If I have better hardware, I can bring better experience, but I need to ensure that I can provide a basic functionality that the user can use the application for the purpose that it has. So the idea is to bring the user better or similar experience even when we are not in the ideal context, even when we are in the subway, for example. And what I like about PWAs is that they are trying to resolve the gap that we already have between mobile and web apps. Browser is becoming the main actor, of course, and the great thing is that using these technologies or these practices is where we can reduce that gap. So native apps has these OS features that are great, but we cannot reach audiences. So it's not the ideal scenario. Then we have the web apps that don't have OS features, but can reach more people. But again, it's not the ideal scenario. So the idea is to use progressive web apps to fix that gap, where we have the OS features, we can access the devices, we have push notifications, we have the camera, whatever, and we can still even reach people. We can share our app, we can search or access our app through a search engine. We can reproduce the application through a link. So everything is easier when we are talking about web applications. So this is the real scenario. This is what we need to achieve. Which are some advantages that I found, especially the deploy or the distribution of the application. It's easy because I can deploy to the web, I can update easily, and I can avoid installations in the stores. I can bring offline support, of course, the same thing that I have in native apps, I can do it now with the web apps. It's cross-device. That means that my application should work in my phone, in my tablet, in my smart TV, in my smartwatch, in whatever kind of device that supports JavaScript, HTML, and CSS. My application should work and should behave the same way. I have only one source code, and of course it could depend, but in the most scenarios you are probably going to have one source code. Maybe you have some if conditions for tricky things depending the device, depending the OS, but technically you have just one source code. And this is my favorite, at least, that I was facing a lot of stores. You don't have to deal with the stores. You don't need the iOS approval. You don't need the Android approval. You can just distribute your application because it's the web. So bye-bye stores. And imagine a world without stores. Could be something like this. So the idea behind, or the 4 concepts behind the PWAs, or that we need to achieve in order to get a good experience in a PWAs, it's basically FIRE. And the F is for fast. Our application needs to be fast, and the initial load needs to be fast. Most of the users abandon the site if the page load takes more than 3 seconds. So we need to get an initial load fast, and of course, the rest of the flow should be fluid and fast enough too. We can try to reduce the initial time using some techniques, code splitting, etc. But in general, now that we are tending to these single-page applications where everything is slowed at the beginning of the usage, the initial load is really slow. So it's something that we need to take in mind in order to get a good user experience. It should be integrated. And why the dog is there? Well, basically because if something has 4 legs, barks, and eats, it's a dog. So here is the same. If our application looks like a native app and behaves like a native app, will be a native app. The user don't really care about the code or the language that we are using to code that application. If we can integrate the OS stuff or get all the capabilities we want, we can trick the user and bring the same experience that they should have with the native application. Should be reliable, and that it's the idea behind the offline support. Should work in any kind of context. At least a minimum or an MVP should work in any kind of context. We need to optimize resources, take care about the usage hardware, the hardware usage, like the battery. Our application should be discoverable. That could be accessed through the search engines, could be shareable through a link. And also the R for me is for resilient, that should work in or should be able to recover from errors or for unexpected things that could happen during the flow of the usage. So those are the things that are for reliable. And the last one is that should be engaging. Okay, if I am in Twitter, I want to tweet. If I can't accomplish the mission that the application it's supposed to do, probably I will lose my users, I will lose my customers. So the idea is that should engage the users. Of course, I can use other techniques like the native apps. The most common techniques to engage users is the push notification. You get the notification, you open it, and you are directly inside the application or inside in a specific part of the application. So we need to replicate that kind of behavior here. Okay, so far so good. We have, or we know everything we need to, or we are convinced to start using progressive web apps. So let's see what we need now to start creating them. As I mentioned before, the browser is the main actor here. We are going to use the browser for everything. The browser will run our application, so we need to rely on the browser. We need to bet in the browser. And this is a cool site that you can check later, what web can do today. And it basically shows you all the APIs, all the features that your browser supports now. Probably you know most of them. Probably there are a lot of them that you don't know. So the browser, it's really powerful. We can access the camera, we can access the USB. Maybe we can't send SMS, but most of the features that we probably use usually or daily for progressive apps, we can have it here in the browser. And this is great. We have, as I mentioned, we have push notifications. We can, even with the browser in background or with the application in background, we can get push notifications that triggers a message and redirect to our website later. And this is great because this not only works on mobile phones, it also works on desktop. You are probably familiarized with push notifications. Using some other technologies with push notifications, we can make web push notifications in background, and that is great. Even with the browser closed, we can make it happen. The second important thing is the web app manifest. This is a JSON file, a pretty simple JSON file, where you set up some application metadata, like the name, the icons, the description, some other kind of stuff, where you can set how your application will behave anytime the user wants to install it. Remember that I mentioned the PWA, the idea behind it is to make it the home screen or simulate the native behavior. So using this file and setting up some properties there, we are letting the browser know that we can use or it can trigger a prompt and let the user know that this application could be installed. And we'll create an icon in the home screen similar to any kind of app. So what you see here is a web app. This is the procedure where the browser asks to install it. I install it here with this icon. All of this data is defined in the meta in the manifest JSON. I can even have a splash screen of my application, and then the same application will look like a native app without the browser URL, without the browser configuration, so will behave like a native app. Of course, that depends on me or how can I apply my styles, but I have everything there in the side of the browser now. And this same behavior could be replicated in desktop too. I can install applications in desktop and have a full Chrome extension experience, for instance, with a progressive web app. The last thing that we need is service workers. And service workers are the key here because it's what allows us to use our application offline. A service worker is basically a script. How many of you use service worker before? Okay. So it's basically a script that runs in background. Remember that JavaScript, it's single thread. So service worker is single thread too, but in a different one. So it runs in background and it could interact with the JavaScript main process using events. It has some limitations. For instance, it only works with HTTPS. It doesn't have DOM access. It has, or it's asynchronous, so everything needs to be with events. But we can use this stuff as a proxy that will interact with our network and with our browser cache. So using this stuff, it's where we can leverage what things we need to use from the internet, what things we need to use from the cache. And in this chart, you can see that how it works. So we have the browser here, we have the page, we have the service worker. Anytime we are trying to fetch a file or we are trying to fetch an API, that request will go through the service worker. And inside the service worker is where I can handle if I want to go to the internet because I have connectivity, if I want to trigger whatever I have in the cache. So that depends on me and of course depends on the context, and I can decide what to do there. Okay, how I want to handle that flow when there is no connectivity or when there is a different scenario. And the problem with service worker used to be that wasn't support for Safari, but right now it's widely supported. Almost all the new browsers are supporting it. So we can use service workers in iOS, we can use it in Android. So basically we don't have an excuse to not use progressive web apps or to apply progressive web techniques to our app. A service worker code, it's quite easy. We have this is the service worker file. So we have self, that it's like the global scope for the service worker. And we just use event listener, the same API or the same pattern that we use for events in the browser. Then the name of the event and the function that we want to trigger anytime that event is requested. Then in our main file, the only thing, main file or whatever JavaScript file that it's using your DOM application, we just need to register the service worker. So only we need to set up the URL or the path of the service worker, and that's it. The service worker will be registered and will start working depending on your rules, and will start caching or distributing your requests according to your needs. So this is, at least for me, the priorities that you need to achieve in order to get a fully progressive web app today. The first thing, it's making installable. The second thing, it's making or to cache the app shell. I call the app shell the main structure that your application needs to look good. You know, the main CSS with the JavaScript, with the main HTML. So maybe your application will not work, but we will avoid the Chrome dinosaur and we can show you show the user a better friendly message, or at least the latest content that they have. Then you can start playing with dynamic cache, basically caching the API, or decide where to invalidate the cache, or where to request through API, or when to distribute from the cache. So try to leverage that according to your needs. And if you feel brave, you can use background sync and push notifications. Background sync, it's basically a new feature. I think it's only supporting Chrome, but the thing now with the service workers is that you only request, get, and cache data from the server. So with the background sync, it's the opposite. Imagine that we are in Instagram, we want to post an image, but we don't have internet now, so we can use service worker to save that post request in memory or in the cache, and when the apps recover when the connectivity gets on again, that could be triggered in background, even if the user is not in the application or in the browser, could be triggered in background and make the post request that we want. And for push notification, it's basically the same. It's a process that runs in background, and service workers allow us to use it in conjunction with the web push notifications API. So what's the deal with Vue.js, or what Vue.js can do for us in this context? Well, especially I love Vue.js because it has a great developer experience. I am using a lot, and the ecosystem of Vue.js is great. They give you a lot of choices, a lot of tools, and you can pick whatever fits better for your team or for your project. So what I mostly like about it, it's the developer experience. You have a lot of tools that you can use to create your application, to make it work, to make it easy to distribute, to compile to whatever you need in the development workflow. And the first thing that we need is the Vue CLI. The Vue CLI is the scaffolding tool that you can use in Vue to create Vue.js applications. Most of you already work with it, so you're probably familiarized. You only need to install the CLI through npm, and then you just need to create a new project. Using those two commands, you will have a Vue.js application running locally in your machine. Then we have PWA plugin. What is this? Well, basically, the CLI is composed through plugins. So anytime I create a Vue.js application, I can mix different plugins like TypeScript, Babel, ESLint, PWA, the Vuex, the Vue router, whatever I want. I can pick the plugins I want and create an application in base of those plugins. If I have an existing application, this will work too, because I can add a plugin to an existing code without changing anything, without migrating the project. So this line of code will add the PWA plugin to my application without breaking anything in most cases. Yeah, I can ensure that. But it's simple to use, okay? This will just create a set of files that will handle the service workers for you with Webpack, and you don't need to take care about any setup or any hard configuration. So this is an example of this flow working. You create the name of the application, then you can pick the plugins you want. You can set if you want the files in the configuration files in different files or in the package JSON, and that's it. It will create the application for you. It's quite easy. So with this, you will have a running progressive web application in just a few seconds. I'm not sure if you can see it, but this is the scaffolding, the basic scaffolding you get after running the CLI. And if you compare that with a normal Vue.js application, you will have two files there. The first one is the manifest.json, the file that I told you before. And the other one is a file, register service worker. The last file is the Vue config.js, that it's an optional file that you don't need it if you don't need to override the config. If you want to customize the configurations, you need to add that file and put your stuff there. But if you go out of the box, you don't need that file. I will talk about that later. So imagine that you want to configure that file. So you just need to create, you want to extend the setup configuration. You just need to create it, and all the setups for progressive web apps are inside a property called PWA. So there you can put all the metadata, the things that we saw before in the manifest.json file, you can put it there. And the plugin, Webpack, everything in compile time will make magic for you and will distribute that for the web. The other important thing that we need to know is Workbox. Workbox, it's a set of libraries and modules to add offline support to our application. It basically removes the boilerplate that we have when we start working with service workers. Service workers are great, but sometimes it's really painful if you have a lot of code, if you have to unregister them, register them again. So it's like a tool running on top of the service worker API. It's a Google tool. It's cool. It's really cool. And basically, you can write in 3 lines of code the same thing that you write with 10 lines of code in service workers with the vanilla API. And of course, as CLI is using Webpack, we have a Workbox Webpack plugin that it's the one that it's Webpack use. The CLI use when you run your build process or your setup process, even for the development workflow. So all the magic, all the configuration for the progressive web app, even for the Vue compilation, it's happened through Webpack, and one of the main actors in the PWA stuff is this plugin. You can check the configuration online. Here you have the links, and I will share the slides later. So everything there, it's interactive. You can check the links and documentation later. And this Workbox has 2 different modes. The first one is the generate service worker. It's basically fast food. Okay, if you want it fast and you want it working now, you have it. But it's simple. It has some limitations. The default setup is what you get when you create the application with the CLI, but it's only for pre-cache stuff. So if you have to add more complex rules to your cache system, you need to use another different mode. But if you're starting, you want to play, you want to at least add some basic offline support to your app, this is what you need. If then you want to dive deeper on that, you need to go to the inject manifest mode. It's more elaborated, like sushi. It's more complex, but it's more powerful too. You have more control there. You can, of course, use pre-cache, but you can use routing. If you are using, for example, web push notifications or background sync, you need to use this mode. You are not able to use the other mode. Something I forgot to mention is with the other mode, you don't need to create a service worker file because Webpack will create it for you. In this case, this inject manifest mode will need you to set up a service worker file. So if we go back to the Vue config, now we can change the mode that we want to use. Okay, if we were using before the default, we don't need to specify it, but if we want to change to the inject manifest, we need to specify it there. And we have options about where to serve the service worker file, where to locate it, what kind of routings we want to apply. There are a lot of configurations that you can check later in the documentation. And here is an example of a service worker using Workbox. So Workbox has nice APIs to apply different strategies, different cache strategies. So for instance, this is a cache first strategy. In this case, what I am telling to Workbox that will create a service worker that will cache everything inside the image folder. So the strategy that will apply is that the content, if the content is in the cache, will serve the cache. If not, we'll go to the network and get the resource from there. But then, for example, we have the opposite. We have the network first approach, where we set the same thing, a regular expression, where we want to trigger it, and then the kind of strategy. So in this case, the application will go first to the network, and if something wrong happens, like there is no internet, it will serve the content from the cache. So for dynamic content, it's probably this is the best approach. For static content, the local cache is or the other cache first strategy is the best approach. And another strategy is network only. Imagine that you are dealing with authentication. So anytime the user authenticates, you want to go to the authentication server. So okay, for authentication stuff, we always use the network. We never use the cache. So those are different strategies that you can apply in your code, and you can leverage that to use in your application. Of course, the rules, the things that you want to apply, the things that you want to cache or not, depends on you and your business model. And this is an example, a more complex example using background sync. But for background sync, it's quite easy doing with Workbox. It's more complicated doing that with service worker. but you need to create a sync queue that it's something that Workbox provides. And basically this sync queue, it's something where you queue elements that you want to sync in background later. So if for some reason your application fails to go to the server, you can put elements in this queue, and then anytime this regex match, the strategy will, the request will add to the queue, and then anytime the application recovers from the offline error, you will be able to trigger this post. But everything of this will happen in background, will happen even if the user has the browser closed or the tab or the application closed. Lastly, we have the register service worker. This is the file that I showed you at the beginning. And this is another kind of plugin that you have in Vue. It's quite easy. It's just a file using a small library that's called register service worker. And it's a kind of shortcut to register your service workers without using the native API. The good thing is that you can put, of course, a relative URL. You can customize this URL if you want, but this is the default behavior. Okay, if you don't specify a different path for the service worker, this is the one that Vue.js will try to use. And there you have different hooks. You have ready, cache, updated, offline, error. Those are hooks where you can trigger code or update code anytime those events are triggered by the browser. Okay, so if you want to do something or know when it's ready, you have the hook there. You have the hook for cache, updated, offline, etc. This is another example. This is the application that you will have when you create the app using the procedure I showed you before. So you can see there that I am trying to reach from the API. I am online. Then I can deactivate the offline there in the tools. And if I try to reach the page again, the page is still working. And you can see that now, oops, I will put it again. You can see that now the files, instead of being served from the API or from the server, are being served from the service worker. Actually, when you see this, this icon, it's because the file is being served from cache. So let's see it again. Everything of this is served from the API. Now everything is served from the service worker. And the application is still working. I probably will not be able to get the new post or the latest post, but I can ensure that the user could still use this application. Another important technique that it's not technically related to PWA, it's called splitting. Code splitting, I mentioned that because it's part of the process to make our application fast and to reduce the initial load time, especially if we are working with single-page applications. And code splitting is the technical, it's a technique that we can use to reduce the initial time load, where we can split the code in different chunks, in different small files. So instead of having a big JavaScript file with a lot of megs, we can just have different files and request those files as we need it. In Vue.js, it's simple to do that because we have asynchronous components. If you are not familiarized with Vue.js, this is the traditional way that we use to import a component, but this is not asynchronous. So anytime we do this, we are putting the component in the chunk, even if that component is not used. For instance, this is a modal component, so maybe I can show the modal or maybe not, depending what the user does in the app. So replacing that with this, and using Webpack, of course, I will be able to create a chunk from this file, and this file only will be served or will be loaded if I request it, if the user requests it. And the same thing for the router. Again, if you're not familiarized, this is the way that you can use in Vue to match routes with components. So you have the route it's a path in the URL, and then you set the component. So anytime the user goes to / I will show the home component. And this is the traditional way, using the synchronous load. And this is the code splitting way, where I can set up the path, set up the name again, but I use the import and the Webpack chunk name to import the component in a synchronous way. It's an important technique. It's not technically related to PWA. I recommend you to use it in general if you're working with Vue.js, because it will save you a lot of time, or will reduce a lot the load time of the first load time of the application. This is important to have in mind. As Phil Carton said, there are only two hard things in computer science: caching validation and naming things. Unfortunately, if we are working with PWA, we need to deal with both. And what I mean with this is that we need to test locally everything. Cache could be tricky sometimes. The service worker could be tricky too, because sometimes we don't notice when the service worker was updated or not, or we need to reload the page. How service workers works, it's that you update the service worker, but it's not installed yet, because something could be happening in the middle. So to avoid breaking changes, the browser stops the installation until you close the tab and open it again. So sometimes this kind of stuff could be tricky and could be get you to miss or to false positives, right? So to avoid that kind of stuff, always test locally. So using the CLI, you can, well, using serve, first of all, it's a HTTP server command that you can install with npm. Then you can build your application using Vue.js, using the CLI. This command, it's the default command for build when you create the Vue app. And then you use serve to make an HTTP server under the dist folder. That is where Vue.js make the build. And if you run your application, that it's now running in the distribution, you will see here a lot of workbox messages. And this is pretty useful for debugging and to know what is happening here. Of course, I am seeing this because I didn't build my application for production. I built it for development. If I build the application for production, I will not be able to see this. But if I build for development, I will be able to get some understanding of what is going on there, what workbox is caching, what it's not, etc. And one of the last things, it's Lighthouse. Lighthouse, it's a tool that it's now part of the Chrome Dev suite, where you can audit your applications in terms of performance, progressive web apps capabilities, accessibility, and best practices. So you can run this tool and see what is going on with your app in terms of these things, especially PWA. And you can get messages about the things that you are doing wrong, the things that you are doing good, the things that you can improve. You can get tips there. And it's also a node module. So you can run Lighthouse as a node module. So that it's great because you can use this stuff as part of your CI, for example. So I don't know, maybe we can set up our CI that needs to reach at least 80 rate in the PWA score. So if we don't reach that, we can break the build or we can avoid publishing to production. So it's a great tool, and it's probably something that you are going to use anytime that you work with progressive web apps. This is my checklist. So if I want to create a Vue or a progressive web app, this is at least the checklist that I will try to meet. And most of the items, of course, it's really hard to meet everything, but these are the things that I will try to keep in mind. The first one, of course, it's offline support. At least it's the most important for me. The second one, it should be available in all browsers. Any context, and it's related to offline support because the worst context that we can have in a web application is not having internet connection, but could be different situations that maybe some third-party API is broken or some service is down. So it's not only about connectivity, it's also about integration. Better resources means better UX. Okay, if I have a better display, if I have a bigger screen, if I have I don't know, a better camera, I need to bring a better UX user experience to the user. If not, I can ensure the basic functionality. HTTPS, always need to use HTTPS. It's 2019. There's no reason to not use HTTPS. Should be installable, and that is quite easy to do. We have to set up metadata. We have to let the browsers know what we are or what the user are trying to install. Should have fast initial load. Should be fluid, okay, because this is part of the native experience, right? The native applications are fluid. We can't use an animation that makes everything slow. We need to take care about that. And one page should be one URL. It's really important, this for me. We should be able to reproduce any part of the application with one link. We need to be able to get that link, share with a friend, and that friend should be able to see the same content as we are seeing. That it's something that it's hard to do now with apps, and it's an advantage because in the web it's really easy to do. It's just sharing a URL. And to close, this is the tip of the iceberg. There is a lot behind it. I encourage you to keep researching, to start building progressive web apps, maybe not with you, but with any kind of technology. But take in mind that there is a lot that you need to dive deep in order to get good or great applications working with these practices. Here are some resources. Workbox documentation is great with a lot of guides. It's done by Google, so it's great. Service workers, it's a kind of book online from Mozilla. It's good if you want to learn about service worker without dealing with Workbox, that it's on you. Lighthouse is a tool I mentioned before, and it's something that you will use because we'll guide you through the PWA development. And if you need to combine bosses or tech leads or whatever, you have PWA stats, and you can get some relevant information there, and I don't know, find reasons to start using progressive web apps in your projects. And the final thing that I have to say is, if it has 4 legs, it's a progressive web app. It's a black box for the user. So if it behaves like a native application, if it looks like a native application, the user will think that it's a native application. They don't care about the language, they don't care about the technology, they only want a good user experience and want to be able to use the application in any kind of context. Thank you.
Wasn't that fantastic? I feel like I've learned a huge amount with that one. I think it's also important to point out that any website can become a progressive web app. It doesn't have to be an app or anything. You can add service workers and manifest on there, and you get all these benefits that you've talked about. It's wonderful.
Yeah, that's it.
We've got a question coming in from the live streams, from the internets, because please remember, we've got slido.com, and you can ask any questions that you want to on there. How do push notifications with the browser closed work? And for me, I think that's a broader question about background processes.
Okay, this is, well, push notification is probably one of the hardest part because it's not only browser. You need to use some sort of system to trigger those notifications. At least in Chrome, that it's the way that I implemented. It's quite new. You need to use Firebase Cloud Messaging. That it's the same tool that you use for push notifications in Android. Even you can use it in iOS. So you need the notification server. You need to trigger the notifications through Firebase. And of course, you need to use the service worker and set up the service worker with an event to be able to catch the messages that Firebase will send to the service worker. It's just kind of integration between the browser and the notification server, and the browser needs to support that notification server.
Cool. I think that's good. I can't remember if you actually answered this. I remember you talked about cache invalidation. But how do you invalidate something like a service worker cache?
Well, you can invalidate the cache manually anytime you want because you have access to the cache. Of course, if we are using Workbox in the simple mode, we don't have a lot of control there. But the thing that we have is that anytime we build the application, Webpack creates different kind of chunks with the versioning. So the builds will take care of invalidating the previous cache. So anytime you create or you build the application again, the old cache will be invalidated. But of course, you have access to the API if for some reason you need to do it manually.
Cool. And we've got one last one that's just come through. How many of these apps have you built?
How many?
Live?
Technically, only one. Only one that it's online. It's really hard to let the companies or make the companies bet on this because, you know, why we are going to create a new progressive web app if we already have applications in our stores. But I only have one in production, and I hope I can have more soon. But, well, only one.
It's cool. I've only done one as well. It's fine. I think we need another huge round of applause there for Nacho.
Thank you.